The viability of human habitation on Mars, the challenges and potential solutions. Mars, the fourth planet from the Sun, has long captured the imagination of humans as a potential destination for colonization. However, the harsh conditions on the Red Planet pose significant challenges to human habitation. In this detailed exploration, we will delve into the reasons why Mars may be uninhabitable for humans, examining its atmosphere, temperature, radiation levels, and geological conditions. Additionally, we will explore potential solutions and factors that might make Mars a viable option for human settlement. Thin atmosphere. Mars has a thin atmosphere composed mostly of carbon dioxide, with traces of nitrogen and argon. Unlike Earth, where a robust atmosphere provides a protective shield against harmful solar radiation, Mars lacks this safeguard. The thin atmosphere allows more cosmic and solar radiation to reach the planet's surface, posing a significant threat to human health. Mars has a wispy atmosphere that is only about 1% as dense as Earth's. This thin atmosphere provides little protection against cosmic and solar radiation. On Earth, our atmosphere serves as a shield, absorbing and scattering harmful radiation, making life on the surface possible. Without this protective barrier, Mars leaves its potential inhabitants exposed to significantly higher levels of radiation, posing severe health risks. Mars' thin atmosphere not only exposes its surface to radiation but also affects weather patterns. Unlike Earth, where atmospheric pressure supports liquid water, Mars' low pressure causes water to either freeze or vaporize. This limits the possibility of liquid water bodies, essential for sustaining life as we know it. Harsh temperature extremes. Mars experiences extreme temperature variations, with average temperatures hovering around 80 degrees Fahrenheit, 62 degrees Celsius. The lack of a thick atmosphere results in minimal heat retention, causing temperatures to plummet during the night. Such harsh conditions could make it challenging for humans to survive without advanced thermal protection. Mars experiences temperature extremes due to its thin atmosphere, which struggles to retain heat. The lack of an insulating atmosphere results in rapid temperature drops, particularly during the night. Surviving these frigid conditions without adequate thermal protection poses a formidable challenge for human settlers. Temperature fluctuations on Mars are not only limited to diurnal changes but also seasonal variations. The absence of a thick atmosphere contributes to an inability to retain heat, leading to extreme cold. This poses challenges not only for human survival but also for the cultivation of crops, a critical aspect of sustaining a Martian colony. Radiation exposure. The absence of a strong magnetic field and thick atmosphere exposes Mars to higher levels of radiation from the Sun and cosmic rays. Prolonged exposure to such radiation can have detrimental effects on human health, increasing the risk of cancer and other radiation-related illnesses. Mars lacks a strong magnetic field like Earth's, which helps deflect solar wind and cosmic rays. Consequently, the surface of Mars is exposed to higher levels of radiation, including ionizing radiation that can damage living organisms at the cellular level. The impact of radiation on human health extends beyond immediate dangers. Prolonged exposure increases the risk of genetic mutations, affecting the long-term viability of potential Martian colonies. Limited water resources. Water is essential for human survival, and Mars has limited accessible water resources. While there is evidence of water ice on the planet, extracting and purifying it for human consumption and agricultural purposes would require advanced technology and infrastructure. Water is a fundamental requirement for human survival. While evidence suggests the presence of water ice on Mars, its accessibility and extraction present challenges. The scarcity of water resources hampers the feasibility of sustaining human colonies. While water extraction is theoretically possible, the energy-intensive nature of the process presents challenges. Additionally, the need for large quantities of water for agriculture and daily life requires efficient and sustainable water management systems. Gale-force dust storms. Mars experiences frequent and intense dust storms that can engulf the entire planet for extended periods. These storms reduce visibility, hinder solar power generation, and pose challenges for life support systems and equipment. Mars experiences intense dust storms that can engulf the entire planet, reducing visibility and posing risks to both equipment and human health. These storms, fueled by strong winds, can last for weeks or even months. Mars dust storms are not only visually dramatic but also pose practical challenges. The fine dust particles can infiltrate mechanical systems, potentially causing malfunctions and reducing the efficiency of life support equipment. Gravity differences. Mars has only about 38% of Earth's gravity. Prolonged exposure to lower gravity levels could lead to adverse health effects on the human body, such as muscle atrophy and bone density loss. The long-term effects of reduced gravity on the human body are not yet fully understood. Muscular and skeletal changes may affect the ability of Mars settlers to adapt to the unique gravitational conditions. Potential solutions and habitable factors. Greenhouse gas emission. Introducing greenhouse gases into Mars' atmosphere is a proposed solution to thicken the atmosphere and trap more heat. This process, known as terraforming, could create a more Earth-like climate and mitigate temperature extremes. While terraforming, introducing greenhouse gases to thicken the atmosphere, is a theoretical solution, implementing it on a planetary scale poses immense technical challenges. Scientists are exploring the feasibility of creating localized environments with thicker atmospheres within habitats to shield humans from radiation. Localized terraforming within enclosed habitats is being considered as a more manageable alternative. These controlled environments could provide suitable conditions for human habitation, allowing for the cultivation of crops and sustaining life. Radiation shielding. Building habitats with advanced radiation shielding materials can protect inhabitants from harmful radiation. Additionally, underground structures or habitats with thick walls can offer natural shielding against cosmic and solar radiation. Radiation shielding materials, both natural and synthetic, are being researched to provide adequate protection against the harmful effects of radiation. Habitat design considerations include the incorporation of shielding layers to minimize radiation exposure to human occupants. Innovations in both material science and architecture are essential. Designing habitats with built-in radiation protection, combined with the use of shielding materials, can create safer living spaces for humans on Mars. Advanced thermal protection. Developing advanced thermal insulation technologies and materials can help humans withstand the extreme temperature variations on Mars. Insulated habitats and spacesuits are crucial for maintaining suitable living conditions. Advanced thermal protection technologies, both in terms of clothing and habitat construction, are crucial. Insulated habitats equipped with temperature-regulating systems, as well as spacesuits designed for extreme cold, are essential components of any potential mission to Mars. Research focuses on developing lightweight yet highly effective thermal insulation materials. These materials would be integrated into spacesuit design and habitat construction to provide optimal thermal protection for human occupants. Water extraction and recycling. Mars water resources can be harnessed through advanced extraction techniques. Additionally, efficient water recycling systems within habitats can ensure a sustainable and continuous water supply for human needs. Advanced techniques for extracting and purifying water from Martian sources are under exploration. Additionally, closed-loop water recycling systems within habitats are being developed to maximize the efficient use of available water resources. Exploration missions are actively searching for accessible water ice deposits. Once identified, extraction techniques will need to be developed to harness this valuable resource. Closed-loop water recycling systems within habitats are also being perfected to minimize water waste. Dust storm preparedness. Designing structures and equipment to withstand dust storms and developing advanced forecasting systems can mitigate the impact of these storms on human activities. Implementing protective measures, such as seals and filters, can also minimize dust infiltration into habitats. Structural engineering and design can play a critical role in developing habitats and equipment resilient to dust storms. Seals, filters, and other protective measures are being devised to prevent dust infiltration into living spaces and sensitive machinery. Structural engineering, including seals and filters, is vital for preventing dust ingress into habitats and machinery. The development of reliable dust storm prediction models allows for timely evacuation or protection measures. Artificial gravity solutions. Research into artificial gravity solutions, such as rotating habitats, could help counteract the effects of low gravity on human health. These innovations aim to simulate Earth-like gravity within enclosed living spaces. Research into artificial gravity solutions is ongoing. Concepts such as rotating habitats, where centrifugal force creates artificial gravity, are being explored. These solutions aim to maintain physiological health by replicating the gravitational conditions humans experience on Earth. Concepts such as rotating habitats, which simulate gravity through centrifugal force, aim to counteract the negative effects of low gravity on the human body. However, implementing such solutions on a large scale remains a complex engineering task. Thanks for visiting Galileo and TED and watching The Viability of Human Habitation on Mars: The Challenges and Potential Solutions. Please like, subscribe, comment, and share.